Hello, my name is Professor Johnson, and today I will talk about absolute value inequalities. This first part will be just an intro working with absolute value. So first I'm going to give an equality. Okay, that's just with the equal to. Okay, so here we have absolute value of x is equal to 6. This means that the distance between x and 0 is actually just 6. So that is 6 is relating to that equals to 6. Okay, so let's draw this on the number line and think about what is going on here. So I will mark 0, and the distance between x and 0, so x and 0, you could think of x going in the positive direction, would go out to 6, is 6. So is 6, I could think of exactly on that value of 6, equal to this spot, would be a solution. If we check this, well, absolute value of 6 is positive 6. We know that that for sure is true. So we have part of the answer. But we know that we could go this distance as well, a distance of 6 away from 0. And away from 0, if you go left, it would really be negative 6. So negative 6 also works out. So I'll put a solid dot here to represent that it is included, right? The equal to does include negative 6. And if we check over on the right, absolute value of negative 6 is also positive 6 as well. So it does check out. Just keep in mind, whenever you take absolute value of anything, you will get a non-negative number. Okay, let's work with an inequality now, okay? So an inequality, absolute value of x is less than or equal to 6. So now we've changed it up a little bit. Less than or equal to 6. So this means that the distance between x and 0 is less than or equal to 6, period. Okay, so then I will just highlight that. In green represented that inequality where I highlighted in green there. So what I like to do is think about like a balance beam. So let's just imagine, here's a balance beam, just draw it the best I can, and let's say we have a little person standing here in the middle, okay? And we know that if they walked to the right, let's say that they could go 6 feet to the right. But as soon as they go like 6.1 feet, they will fall off the beam, and that's bad news, right? They fall off and hurt themselves. Also, let's say they're in the center of the beam. If they walked to the left, they could also walk to the left 6 feet, but they need to walk less than 6 feet, because if they go 6.1 feet to the left, well, then they fall off here, and that's bad news as well. So you can see that this is kind of mimicking this less than or equal to 6 idea, right? You could go less than 6 feet that way, or less than or equal to 6 feet that direction, right? So let's think about this with the number line. Let's make a number line. Let's mark 0. So kind of pretend that that's where your person was standing, right? At the origin in a way. And you could go a distance of x to the right, but it has to be less than or equal to 6. So I could go to 6. I will include this endpoint because of the equal to, right? The equality will include that. Also, I could go to the left, right? When you think about distance, you could, like thinking of the balance beam, you could walk left. That's totally fine. A distance of x. Okay, and I will include that as well because of the equal to, right? It's just less than or equal to 6. But we know that, like, if you're on the balance beam, if you walked a little bit to the left over here, right? If you walked over here, this also works, right? Or if you walked over here or over here, anything through this whole beam, right? If you think of it in that world, anything would work in here. So actually, our solution would be anything between negative 6 and positive 6 would work. So another way to represent this is, so x could be between negative 6 and positive 6. That is one way to represent it. Another way is to work with interval notation, and I will start my interval notation with a bracket because we are including the -6, and then we go, imagine that you're walking right along the balance beam, you get up to +6, I'll put another bracket because that is where you end, right? You know that if you go to 6.1, you'll fall off and hurt yourself, right? So you could imagine that -6 to +6 is our solution in interval notation. A couple ways that you could check this, right? If you take the absolute value of -6, is this less than or equal to 6? You ask yourself that. Well, yes, it is, because absolute value of -6 is 6, and 6 is less than or equal to 6. That is true. So that would work if you checked it. Let's check another value. If you checked like -3, well, the absolute value of -3, so let's think about that, is +3. Now, is +3 less than or equal to 6? Yes, that is true. So 3 is less than or equal to 6. So that would be included. So if you think back over here to our number line, -3 was marked over here. That it is part of our solution set, right? So we know -3 did fall in our interval notation. So we're good to go there. Now, another way to think about this is by splitting it up. So if we look at absolute value of x less than or equal to 6, we could really say that x is less than or equal to 6, and we say that x is greater than or equal to -6. So let's think about where this comes from. X less than or equal to 6. You could actually see that this came straight from here. That's just basically rewriting it. Now, the and part comes from thinking of that idea with the balance beam, right? And if we think of our number line here, well, x less than or equal to 6 right here, that makes sense. That's where it came from. And then we have and, putting it together, x is greater or equal to -6. If we go over to -6, well, marking that endpoint, we must go greater or equal to, because you see how you're going to the right, right? Think of the greater or equal to symbol. If you make that like an arrow, you see how it's pointing right. So we are really walking on the balance beam, right? Only on this part of the balance beam. So we have that x greater or equal to -6. Now, if we put that together, that and statement together, what we could do, so if we make a number line, two number lines really, and we mark where 6 is, and we shade less than or equal to 6, we'd shade everything that direction. And then if we marked -6, and we shade everything greater or equal to -6, right? Taking that blue part and taking that other colored piece. If we take the and statement, we need to put together what overlaps, and what overlaps is matched up with our solution that we had up top, right? It's only shaded and included between -6 and +6. And again, that kind of, it builds our balance beam. If you kind of imagine, right, our person is standing here at the center, right? Okay, so that's one way to think about when you are dealing with an inequality with less than or equal to. This also works a similar way with less than only, strictly less than. You just won't have the equal to, and when you don't have the equal to, well, then you'll have to use parentheses instead of brackets, and you'll leave the end like 6 feet away. You'll leave the end parts open. But we'll get to example of that later on in part 2 or part 3 of the video. So let's deal with an example where we now have absolute value greater than or equal to 6. So now greater than or equal to 6. Well, this means the distance between x and 0 is greater than or equal to 6. Okay, so I'll just highlight that. That's what the meaning is. Now, the way I like to think about this in real terms is Okay, let's imagine you are in a river. Okay, so here's a river, and let's say we are let's make a rock right in the center of the river, and let's just say you are standing right here. Okay, so let's stand right in the middle of the river, but you're standing on a rock, so you're dry. Now, in order to make it to the bank, right, over here, or you could go jumping that way. In order to make that, you will need to jump greater than or equal to 6 feet away. Okay? So if you jump 6 feet, then you will land here and you will be happy, right? But if you only jump like 4 feet, if you jump 4 feet away, well then that's bad news, right? You will land in the water. But, you know, this works in both directions, right? You could jump 6 feet to the left and you'll land safely on the bank. But if you jump 4 feet to the left, well, that's less than 6 feet, so you will have bad news. So that's the way I like to think that. Let's compare that to the balance beam idea, right? An inequality with less than or equal to, you need to be within, right? So you see how that shading with our solution was within -6 to +6. But here, now we want to be greater than or equal to 6. So we're jumping away from. So let's make our number line, and let's, imagine, you're standing here in the middle of the river, right? Just imagine that 0 is where you're standing. Now you need to go X distance away from 0, and really you need to be 6, so we can have equal to 6, but then we need to be greater than, right? Like if you jumped 7 feet, well then that's even better, right? Because 7 or 8 or 100 feet, right? Imagine you're like a superhero or something. That would work, right? That distance of X away, that would work. So I'll just place my X here. Okay, now we could also demonstrate this going towards -6, and -6 could be included because of that equal to. And then let's shade everything to the left here as well. And there we go. That would be our shaded. Now, remember earlier, I made a statement where I said an and statement. Now here, notice how these are separated, right? You have a separate part over here and a separate part over to the right. So what I'm going to do is actually have an or statement when we're with greater than or equal to 6. So over here on the right, on this right side, you can see this shaded piece. I'm going to say over here that this is represented by X greater than or equal to 6. Okay, if we take away the absolute value. This really makes sense, right? X greater than or equal to 6. Okay, or we have the other statement. Let's look over here. Let's compare X to -6. Well, you see how it's pointed to the left, right? So this would be less than or equal to -6. So we have our solution here to be X is less than or equal to -6, or X is greater or equal to 6, right? This in between, we do not want that to be part of our solution. Imagine like our realistic idea here, you'd fall in the river, right? So putting this together with interval notation, we could have -infinity to -6, and I will put a bracket here, and then I will place a union symbol to represent or, and then I will start back up at +6 and go to infinity. And we can see that comes from that blue part, and this other color part comes from that. Union represents or. Okay, thank you for watching part 1. Part 2, you'll be able to watch by following the following link that should pop up on your screen.